So thankfully it's a wonderfully sunny day, and I am going to use this celestial sphere to show where the sun is in our sky right now. And luckily my stairway steps here are oriented exactly north-south. The planks are oriented exactly north-south. The way I figured that out, I just used my compass and I laid it down, and it turns out that north is directly along the line of the plank. And so I oriented this. You can see there's north, east is over here that you might not be able to see, south and west. And there's a little pin in the center that I'm not sure is super visible to you guys right now, but there's a tiny pin, like a straight pin, exactly in the center there that is showing a shadow, which you probably can see, that's pointing almost directly to the northwest. That means that the sun is in the southeast sky right now, and it is 10:12 a.m. on Tuesday, April 1st, April Fool's Day. So what I'm going to do to show where the sun is, so since the sun is projecting a light and then projecting a shadow if there's anything in the way, if I take a pen, you can see the pen's shadow inside of the celestial sphere and on the surface. So what this represents, the yellow clipboard, is the surface of the Earth. The little pin is a person, a tree, some sort of object. You could use any object in there. I had a pencil cap eraser in there at one point. And this point right up here, this is called your zenith. That's the point directly above you in the sky no matter where you are. So if we were to move this bubble over there, the zenith would be over here. Okay, so the zenith, if you just take a look directly above you right now, or point directly above you, that's your zenith. So that's an important point because the sun in New York State never gets over top of our zenith because we're too far north. So the direct sunlight never pops up over top. But on April 1st at now 10:13 a.m., the sun, if I take this pen, the pen tip is going to point directly at that crosshair where the northeast-southwest compass meets. And when I touch the celestial sphere, because this is a dome shape, like the dome that the sky appears to look like when we go outside, this will meet the bottom of that pin right where the sun is right now. So this takes a little bit of coordination, and there it is. So the sun is right there in our sky right now, but I'm going to use a different pen. Okay, so I'm going to create a dot right there, and I'm going to label it (10:14 a.m.). Okay, and I'm going to do this several times during the day today, so that we can create a path of the sun across the sky on April 1st in close to Hamburg, New York, and close to Ellicottville, New York. So I'm at about 42.3 degrees north, so a little bit south of you guys. Okay? And so notice that again, though, we're in the morning, and the sun's in that eastern hemisphere of the sky. Also notice that if we were to split it to north and south, that the sun is in the southern part of the sky. Okay, so right now it's in the southeast quadrant of the sky. And the shadow is pointing again to the northwest, and the sun is up in the southeast sky. Okay, pay attention to the length of the shadow too. And in fact, I made this so it's mobile. I usually staple it down, but I came up with this idea so I could take this off. I can actually mark where the shadow is too. Just do that, and okay, and this always needs to be set exactly the same way each time, so that when we come back and take a look at it, this hasn't moved, but we'll see how the sun moves. So there's the point that I made on there. And again, that's where the sun is in the sky if that were you standing here in Ellicottville, New York. Really close to Hamburg, New York. You can do this too if you have any sort of dome-shaped thing. I believe you can do this with a colander. I'll see if I can dig up the directions on that and see if you guys can go out and do this too, because it is a beautiful day. And if you haven't done your shadow yet, today's the day to get out there 3 times and do your shadow. Good morning again. I tried to get out here about an hour after last time. We got some big clouds coming in, so we'll have to kind of wait for a good sunny spot here. I'm going to just leave this out so I know what time it is, and it's almost exactly an hour after we were here last time. And so, there we go, we got some sun. I'm going to get it while it's out. So here I am again, taking the pen and trying to meet that crosshair where the north-south, east-west directions meet up together. And I just want to make sure I tap this celestial sphere. There it is. So this is 11:17 a.m. It's almost exactly an hour after, on April 1st. And you can also see the shadow. So I'm going to take this off so you can see the shadow. First I'll show this to you. So 10:14 a.m., 11:17 a.m., so almost exactly an hour later. If we were to get a protractor, we could figure out how many degrees that is. But if you figure that the sun moves around us, or appears to move around us, because we're actually spinning, and you know that we spin 360 degrees in 24 hours, if you divide 360 degrees by 24 hours, you come up with how many degrees per hour that should be. So go ahead and do that on your calculators. 360 degrees divided by 24 hours, and see if that makes sense, that that's about the angle to the vertex, which would be the point in the center. Is that the angle that that sun has moved in an hour? Okay, and let's take a look at the shadow. Let's take this off. Put back to where it was. And notice the shadow is actually reduced in size quite a bit. Oops. 11:17 a.m. Okay. And that angle that the shadows moved should also be the angle of degrees per hour that the sun appears to move in our sky, and that actually the Earth is spinning. Okay. Also notice that that has moved a little bit towards the north, as the sun has appeared to move a little bit more towards the south. Okay, we'll come back out in a little bit less than an hour, so close to noon. So here we are, it's just about noon, and it's getting tough to see, I think, from the camera perspective. But I just wanted to put another dot on here for noon. And so some of you may have expected it to be exactly in the center. I want to remind you that we are in daylight saving time. And so looks like it's actually right about here. So we're 43 minutes later than 11:17. We're now at exactly noon. So 12 noon. Okay, and if I take this out, first of all, I'll show it to you. So notice that the dots for 45 minutes apart are closer than the dots that are an hour and 3 minutes apart. And the question is, where do you expect 1 o'clock to be? Where do you expect sunset to be? If we project this towards the east, we can see approximately where sunrise was. And knowing that the Earth spins at 15 degrees per hour, hopefully you used your calculator to figure that out earlier, that we could project back every hour and figure out even what time the sun rises. So the sun is moving in this direction. That means it comes from the east. It's heading more towards the southern sky, and will be heading towards the west as the day goes on. Let's take a look at the shadow. So the shadow of the stick is now a little bit shorter, and that's 12 p.m. Okay, and so right now those are our shadows from about 10:15, 11:15, and 12 noon. Notice again the angle is closer for the ones that are closer in time, the 45 minutes apart versus the hour and 3 minutes apart. Okay, we'll come back here a little bit closer to 1 o'clock. It might be just a little bit after 1 when I get back out here. See you then.